Good afternoon, students. Welcome to the Orion Academy of Sciences. I am Meghdud Bhattacharya, who would be your mentor and guide throughout the years. I will be teaching you physics, chemistry, and biology, mainly focusing on the class 11 and 12 syllabus. But later on, I will be coping up with the class 9 and 10 syllabus as well. So today I thought of starting this video because in this generation, in this genre, I am seeing most probably in West Bengal there are many students who are much more brilliant and capable of acquiring the knowledge are not able to get that much attention from their teachers because they are not able to pay them fees due to some financial issues or something. So I am seeing most of the teachers are avoiding them, are just like showing them rudeness towards them. So with the blessings of all my teachers who has given me the knowledge, today I am taking an oath that I will try to give them education which I have learned through all my years. And if they focus on these videos, if they watch these videos, then I can guarantee you that they are going to get a good securable marks in their exams if they follow me. That's it, and now we can start with our syllabus. So today I will be making you learning physics, and the first chapter which we deal in class 12 is electric charges and fields. So what we can say about electric charges and fields? First thing we can say about it that electric charges have unique properties of attraction, repulsion, conduction and induction, which causes many specific effects associated with it. So in this chapter we are mainly going to learn about Coulomb's law and its applications, properties of electric dipole, electric flux, Gauss's law and its application, and the electric field produced by complex distribution of charges. So much we are going to learn about it. But what are actually charges? There are two kinds of charges we can deal with, that is one positive charge and one is negative charge. We also know that like charges repel and unlike charges attract. How we can give this example that like charges repel and unlike charges attract? So let's start. So electric charges and fields. So what do we see? We see over here that the SI unit of electric charge is Coulomb. What is its symbol? We can consider it as C. What is the charge of a proton? A proton has a positive charge and what charge does an electron have? An electron has a negative charge. How we can say it? Because in the nucleus we can mainly see there is plus proton and neutron, that is neutral, and then outside the orbit we see that there are electrons which are negative. They revolve around it in a circular path. So now, what is the charge of an electron? What is the charge of it? Minus 1.6 into 10 to the minus 19 Coulomb. Today I will be mainly dealing with the basics. So I am first starting with the basics, then we will go to the higher level as we continue the class. For that you need to watch all my videos, and you also need to like, share and subscribe, and share as many as possible. As many friends as you have, you can share to all of them. Now, who first observed the two types of charges? It was William Gilbert. William Gilbert. What did he observe first? He observed two types of charges. Two types of charges. And who gave the proper concept about it? It was none other than Benjamin Franklin. Benjamin Franklin was a scientist who gave the proper concept of charges. Benjamin Franklin. We already know a story about him that he was flying a kite during a thunderstorm. We already know. And he just kept a metal key on his hand, and then a wire which was connected to the kite. Then what happened? A lightning struck it and he felt the charge on it. That was a story which we had heard about. Now, what we can say, that like charges always repel. Always repel. And unlike charges, always attract. If someone forgets, then what is the trick for it? Plus plus repel, minus minus repel, plus minus attract, minus plus attract. We had learned in mathematics that plus plus is equals to plus, so we can tell that it is repelling. Minus minus is equals to plus, we can say that it is repelling. Plus minus, that is equals to minus, that means it's getting attracted. And minus plus vice versa is always the same. So now, what differentiates the two kinds of charges? That is none other than polarity. Polarity of charges. What does it do? It differentiates the two kinds of charges, that is positive charge and another one is negative charge. Now what we can tell, that if an object possesses an electric charge, then it is said to be electrified or charged, and when its net charge is 0, then it is said to be neutral, just like neutron. So what we can tell, that if an object possesses an electric charge, then it is said to be electrified. Give two examples for it if asked. Then protons and electrons are the best examples. According to a nucleus, according to John Dalton's theory that an atom consists of three things: protons, neutrons and electrons. And if the net charge of the object is zero, then what we can say? We can say it is neutral. Give one example for it. Neutrons, very easy example. Now, what we can say is, what kind of quantity is charge? Charge is a scalar quantity because it has magnitude but no direction. Charge is a scalar quantity because it has magnitude but no direction. Good. Now, what we can say, another thing to mention, that when some electrons are removed from the atom, it acquires a positive charge. Okay, and when some electrons are added to the atom, it acquires a negative charge. I am rubbing it, okay, so that I can write the next line. Please follow, everyone. There are many things in this chapter, many concepts, innumerable concepts. How many concepts you can see? So, when some electrons are removed from the atom, are removed from the atom, it acquires a positive charge. I am writing in a symbolic way, okay? Positive charge. And when some electrons are added to the atom, when some electrons are added to the atom, then it acquires a negative charge. Okay, why to waste time? Negative charge. Okay, now we also think of we are dealing with all kinds of characteristics of charges. So there is another characteristic for it. Charge can be transferred from one body to the other. Charge can be transferred from one body to the other. Then charge can be transferred from one body to the other. We can see in electrolysis using platinum electrodes or copper electrodes or silver electrodes, okay, that charge is getting transformed. Electrolysis is a good example for it. Now, another we can say that charge is invariant. Why? Why we can say a charge is invariant? We'll see. Charge is invariant because because why? Because it does not depend upon the velocity of the charged particle. That is a simple reason. Because it does not depend upon the velocity of the charged particle. Last but not the least point. What is the another point? That a charged particle at rest produces an electric field. These are very important points to come. So please note it down very properly. A charged particle at rest produces an electric field. Very good. Very good. It produces an electric field at rest. So I am going to ask one question that you will be giving me in the comment box. That is a charged particle following Newton's first law of motion. What was the first law of motion? If the body is at rest, then it stays in the rest. But when a body is in motion, it continues in the moving motion until an external force is applied on it to keep the body at rest. So now, a charged particle with unaccelerated motion produces both electric and magnetic fields but does not radiate energy. What was the point? Acha. Please take a notebook with you and write it down properly. The points I am noting down on the board. You also need to write it in your copy for further understanding. So, a charged particle with unaccelerated motion produces both electric and magnetic fields but does not radiate energy. Radiate energy. Good point. First point, what we learned, that a charged particle at rest produces an electric field, but a charged particle with unaccelerated motion, means it is telling it is in motion, produces both electric and magnetic fields, but it doesn't radiate any energy. But what happens when an accelerated charged particle produces electric and magnetic fields, but it is in accelerated motion? What it can do? It can produce both electric and magnetic field, but it can also radiate energy. When it is in accelerated motion. So we can write it down over here. An accelerated charged particle or a charged particle with accelerated motion produces both electric and electromagnetic fields and also radiates energy in the form of electromagnetic waves, and also radiates energy in the form of electromagnetic waves. So the question which I had asked you previously, that is it following the Newton's first law of motion? Yes, it's following. But you need to write the answer. Give me the reason for it. Please write it down in the comment box as well. So now what we can see, another thing to note down, what is 1 coulomb? What is 1 coulomb equals to? 1 coulomb is equals to 3 into 10 to the power 9 ESU. Now you will ask me, hey sir, what is this ESU? We will deal with it. Just see, 1 by 10 EMU of charge. Now you will be asking me, what are these two things, ESU and EMU? What is this? ESU is nothing but electrostatic unit of charge. Electrostatic unit of charge. Good point. And what is EMU? EMU is electromagnetic unit of charge. Electromagnetic see the difference. Electromagnetic unit of charge. And another thing which we need to know, what is its CGS unit? This were SI unit. What is its CGS unit? CGS unit. What do we mean by CGS? CGS means centimeter gram second. If you remember it, that is stat coulomb. Stat coulomb. Coulomb. Good. What is the dimensional formula of charge? You can ask me this question. Sir, what is the dimensional formula of charge? Yes, why not? Please note it down, everybody. 3 into 10 to the power 9. Now, the dimensional formula of charge, units and dimension you also need to remember every dimensions properly. For that I will give you a trick, but after this video, okay. The dimensional formula of charge is Q is equals to 8T. Wow. Another point, very important point. It might come in your exams as well. What is the smallest unit of charge? If asked, then what you will answer? Franklin, which is also known as what? It is also known as ESU. See, I've given you electrostatic unit of charge. This thing, ESU, is the smallest unit of charge. Do you understand it? Yes or no? Of charge. Good. So, what is 1 Franklin is equals to? 1 Franklin is equals to 1 ESU, because both are same. And what is 1 ESU? Equals to 1 by 3 into 10 to the power 9 EMU. EMU. What is charge always associated with? Good question. What is charge always associated with? Charge is always going to be associated with mass. Another point to come, that is how it is associated with charge. For that I need to rub it. Again I am rubbing it. If you are not able to cope up with my flow, you can stop the video and then write it and then again start it. If there is any doubt, please write me in the comment box so that I can understand that what you are faltering in. Then I will be starting to show you how good the chapter is, means how interesting the chapter is. If you don't follow, then you are not going to able to cope up with me. So what is it? Mass of a body slightly changes while charging. Mass of a body slightly changes while charging. Slightly changes. While charging. Good. How? Please explain me, sir. Please. Yes, I'm telling. Just wait. See. Mass. See, I'm giving you a trick. You will never forget. I think so. If you understand it. Mass. M minus del M. When? See. Just see. When it is positive charging and we only learned beforehand when some electrons are removed from what? The atom, then it gets an acquiring positive charge. See, that is for why positive charging we do del M. Now negative charging, simple, plus M. Negative charging, what we will get? Plus M. Just simple. You add like this a circle, mass is equals to M plus del M. See, such a simple concept. Just you need to understand it easily. Okay. Okay. Now, what does this del M means? Now you will ask me, sir, yes, what does this del M means? It is simple. It is the number of electrons transferred during charging. Number of electrons transferred during charging into what? Into mass of electrons. Mass of electrons. Sorry. This is the formula for del M. How we will write it symbolic form? Simple. N into M. N represents number of electrons transferred during charging. That is N, and mass of electrons is equals to M. Simple. You understand? Can I move on to the next part? Let's start. So now we come properties of an electric charge. properties of an electric charge. Good. These were these points or things we were talking about were important points regarding electric charge, and now we are going to deal with the properties of electric charge. Let's see how many properties we can see. So the first property, what is the first property? The first property is nothing but if the size of the charged bodies is very small as compared to the distance between them, then we treat them as point charges. Okay, now let's write, if the size of the charged bodies is very small as compared to the distance between them, as compared to the distance between them, we can treat them as point charges. Point charges. Very good. This was the first property of it. Now, second property. Charge is additive, means it gets added up. How many charges are there? First, just example, you can see that here is one circle. There might be plus Q1, minus Q2, plus Q3, minus Q4, plus Q5, minus Q6. Then what we will do? Ready, sir? Charge is additive. Simple. Plus Q1 plus Q3 plus Q5 minus Q2 minus Q2 plus Q4 minus plus Q6. Simple. Charge is additive. How we can write it? Just statement wise. You also need to prepare it statement wise. That is why I am also writing the statements as well. So what is the statement? If a system contains n number of charges, for example, mentioned above, we just writing mentioned above. You can see I have given it. Then the total charge of the system, then the total charge of the system is obtained. How is it obtained? Is obtained by simply adding their algebras. By algebraic. Sorry, please excuse again me. By algebra. Sum of all charges, including their respective signs. Sum of all charges, including their respective signs. respective signs. Good. Now, second point. This was the first point. This is the second point. Third point is noted down. What is the third point? Third point is none other than the law of conservation of charge. What is the law of conservation of charge? Law of conservation of charge. Excuse me. Conservation of charge. What is the law of conservation of charge? The total charge of an isolated system always remains constant. Total charge of an isolated system always remains constant. Simple. 3 points. And what is the last and the final point? Charge is quantized. Now you will ask me, sir, what is this quantization? What do you mean by quantized? Yes, we are coming in the point. For that I need to rub it again. Okay, this point. I'm rubbing it. First point and the second point. What do we mean by the charge is quantized, or quantization of charge? Quantization of charge. This is the fourth point. Please write it down. Out of this 4 points, this is the most important point. What is the most important point? What we are going to write? Charge cannot have an arbitrary value. Have an arbitrary value. Its value is always an integer. Is always an integer multiple of e. Is always an integer multiple of e. What do we mean by this e? It is none other than the charge of electron. Integer multiple of e minus we can also write, because charge of electron. Okay. Now, how do we write it in general? How do we write it in general? In general, we can write it Q is equals to plus minus in E, where n is an integer. Okay, these are the 4 points. Now, I will be giving you a concept. You need to remember it properly. Okay, please remember it properly. The concept is, please give it a 2-star or 3-star, anything. I am giving it 2-star, but there is some possibility of coming in your exam. So please note it down and please understand. Protons and neutrons are a combination of more fundamental particles called quarks. What are these quarks? These are protons and neutrons are what? Are combination combination of more fundamental particles called fundamental particles called quarks. Simple. Which have charges. Which have charges. What are the charges of it? Which have charges of plus minus 1 by 3. Sorry, you can't see it in the board. I'm writing so much small, so I need to rub it again. Plus minus 1 by 3 E and plus minus 2 by 3 E. Now, isolated quarks have not been observed, hence the quantum of charge is still E. Means, isolated means staying away from each other. That kind of quarks have not been observed. That is why the quantum of charge is still E. I am writing it over here. Quarks have not been isolated quarks have not been observed. Hence, the quantum of charge is still E. Hence, the quantum of charge is still E. Please note it down before I move on to sums. I will be making you understand two sums. You need to understand it properly. Okay, if there is any doubt, you can ask me through the comment box, or there is my number provided in the YouTube channel. You can call me and I can tell you as well. So before that, please note it down. Okay, this one is law of conservation of charge. It just got a little bit, I'm just writing it for you again over here. Law of conservation of charge. Please follow it properly, because if you get cleared with your basics, then it would be more easy to complete this chapter for me, because it mainly deals with the basics more often, because electric charges and field is a big chapter, but we can do it in a precise way by dealing it with the basics, and then if you go into that second chapter, that is electrostatic potential and difference and current electricity, then it will be better for you. But for that, we need to understand this chapter properly. Okay, so I think so you have written it down, so I'm just rubbing it and I'm continue with the sums. Okay, I'm writing this one. So there is a very common question, very common sum which is asked in the exams. Mainly the question is, how many electrons are there in 1 coulomb of negative charge? This question is repeated many more times. I have seen in many schools being asked this question for first unit or in semesters as well. So what is the question? That how many electrons okay, how many electrons are there in 1 coulomb of negative charges. They are in 1 coulomb of negative charge. So, what we the question? This is the answer. Please write it down properly. The negative charge is due to excess of electrons. Good. Very good. Excess of electrons presence. It would be much more better if we write presence. So the negative charge is due to excess of electrons present. Why? Because when electrons are added to the atom, then it acquires a negative charge, and when electrons are removed from the atom, it acquires a positive charge. Now an electron has a charge whose magnitude is, an electron has a charge whose magnitude is, this is a very common sum, whose magnitude is E is equals to minus 1.6 into 10 to the power minus 19 coulomb. Now the number of electrons is equal to the charge Q divided by the charge E on electrons. What is the formula? The number of electrons is equal to what? The charge Q. The charge Q divided by the charge E on each electron. The charge E on each electron. Yeah. Clear? Now we will write it in a symbolic way, that is N is equals to Q by E. So what was the charge? 1 coulomb charge. So we can write here 1. And what is the charge on each electron? 1. Just avoid the sign, okay? Over here in the sum, please avoid the sign. 1.6 into 10 to the minus 19 coulomb. Okay. Now what will be the answer? We will ask sir. Just remember this: 6.25 into 10 to the power 18 electrons. Very good. So you have seen all this. I have written it down. I think so you have understood it properly. So with this I am going to end my class. Hope so you have understood it very well. And in the next class I will be dealing with conductors and insulators as well as Coulomb's law, and will deal with many sums ahead. But for today this much is okay, because just I have cleared with the basics. These are the most basic things. Okay, I think so you have understood it properly. Please go through your notebook, revise it properly. If any doubt arises, there is my number. You can call me, or you can text me in the WhatsApp, or text me in the comment box. I will give you the answer as soon as I receive your notification. Okay, so for today I am ending the class. Bye bye, see you later.